Hi everyone, we're going to continue on with the principle of mathematical induction. This one is number 4. So basically let's look at this. It's arithmetic. The common difference is 4. You see the 4 right here. It's like the slope of a linear line. Arithmetic sequences are linear in nature. And so we got to prove condition 1 and condition 2 to show that the given statement is true for all natural numbers. So condition 1 means we check for n equals 1. So I'm going to replace n with 1 here, and it should equal my first term. So let's see if that works. We're going to 1 times 2 times 1 minus 1. So this is going to be 1. 2 minus 1 is 1 equals 1. So condition 1 holds. So now we're going to check for condition 2. If the statement is true for some natural number k, so let's do for some natural number k, all right, then it should be also true for the next natural number k plus 1. So we're checking for k plus 1. All right. So what we're going to do is we're going to copy down this right here, and we get 1 plus 5 plus 9 plus dot 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 plus 4k minus 3, and we're going to write down our next term. And the next term, and I'm going to do it here. I'm going to show you 2 different ways to do it. Basically, the way you usually do it is you just, everywhere you take the previous term, and everywhere there's a k, put k plus 1 minus 3. So it's 4k plus 4 minus 3. That's going to be 4k plus 1. So our next term is 4k plus 1. Now, if you want, you could have just taken the slope here. The slope of this line here is 4, and added it to the 3. And then you copy down, when you do that, you write 4k. You have to copy down this first part. And negative 3 plus 4 is 1. And you could have done it that way. It's a little more visually pleasing that way. So the next term would be 4k plus 1. And what would the next term be? We're just going to add what? You want to know the next term after. We don't need to, but I'm just going to show you real quick. So we're going to add 4 to that. So the term after this one would be 4k plus 5. Next one would be 4k plus 9. Do you see what I'm doing? I just keep adding 4 here. 4k plus 13. So basically that's how you could do it versus always having to do this part right here. All right. So let me erase this. Just wanted to show you that because that's what I usually do. All right. So this should go back to norm basics. So the next term after k is k plus 1. And I'm going to go ahead and do what I just told you about with this. My slope to this is 2. So I'm just going to add 2 to this negative 1. So I'm going to write 2k. I'm going to write this down. And negative 1 plus 2 is 1. Or you can do this method. Either way. So now that we've got that established, we're going to see what this equals. This is the same as this part right here. And this equals my sum here. So I'm just going to substitute and write k times 2k minus 1. I'm going to add my next term, which is right here, 4k plus 1, and it should equal that. If you want to FOIL this and clean it up, you can, but I'm not going to do that. All right, so I'm going to clean the top up here. So you get 2k squared minus k plus 4k plus 1. This gives you 2k squared plus 3k plus 1. Now it should equal this. Like I said, you could have FOILed this out. If you FOIL this side out, you're going to get 2k squared plus 3k plus 1. And basically, then you can match it up that way and be done. Or you could just factor this side, the left side, and make it look like the right side. And make sure you did it right. So a lot of times, since you already know what it looks like, it makes it factoring easier. So we have proved condition 1 and condition 2. So the statement is true for all natural numbers. Thank you and have a nice day. Bye-bye.